In this video, we're going to work a word problem where the resulting equation is a rational equation. Now, there's already a video before this where we work word problems involving rational equations, but in this particular example, we're going to get a rational equation that results in having to also solve a quadratic equation to get the answer to the rational equation. So it's a little bit different, but this should help to give you a sense of how you might encounter a rational equation in practice. All right, Jesse takes a 3-day kayak trip and travels 72 kilometers south from Everglades City to a camp area in Everglades National Park. The trip to the camp area with a 2 kilometer per hour current takes 9 hours less time than the return trip against the current. Find the speed that Jesse travels in still water. Okay, so the information they give us is the total time traveled to the camp and then back from the camp area. So we'll say that TC is the time to the camp area, and TE is the time to go from the camp area to Everglades City. So he's going from Everglades City to the camp area in Everglades National Park, and then the return trip is from the camp area back to Everglades City. All right, so the trip to the camp area takes 9 hours less time than the return trip, which is against the current, right? So to the camp area is going to take less time than the return trip because it's against the current. Okay, so now we'll say that the speed that Jesse travels in still water is just R, and then the trip to the camp area with the current is RC, and then the home trip against the current is RE. So to the camp area with the current is 2 kilometers per hour, so his speed increases from still water. So the rate to the camp is what? R, his standard still water rate, plus 2. Okay, there's another equation. Now, what else do we know? Well, the trip is 72 kilometers in either direction. That's constant. So we can say what? Distance equals rate times time. So TC RC is equal to TE RE is equal to 72. Okay, there's another relation. Now, we also know that RE is just R minus 2, right? Okay, so now what can we do here? I don't think this 3 days doesn't mean anything. To me, it's kind of confusing. Because are they saying that it took a total of 3 days? Like, was he kayaking for, I mean, I don't understand that. But no, this doesn't mean anything. So now let's make a substitution into this equation here. So TC is what? 72 over RC, right? TE is 72 over RE. Okay? Now let's substitute in RC and RE. So 72 over R plus 2, and then R minus 2. Okay, and there we go. Now we just need to solve this rational equation. And so how do we solve a rational equation? Let's clear the fractions. So we'll multiply by R plus 2 times R minus 2, and we're left with 72 Okay, let's make some extra room here. Okay, so let's simplify both sides. Okay, so we got R squared plus, or minus 2R plus 2R, and then minus 4 Okay. So we've got this 72R cancels. Okay. We add 144 to both sides. You get 288 minus, and then 9R squared plus 36. Okay. So 9R squared is equal to 324. So we divide both sides by 9. Okay. So R is equal to plus or minus 6. Now, remember, we're solving a rational equation here. Let's before we think about the word problem, let's fully solve it. So plus or minus 6, okay, but let's plug each of those solutions back into the original equation. Is there a domain issue? Are we dividing by 0 with plus or minus 6? No. Okay, so now we know that the answer to this rational equation that we set up is R is equal to 6 and R is equal to minus 6. All right. Now let's go to the word problem. Do both of these answers make sense? No, there's no, you can have a negative velocity, but for this word problem, R is equal to minus 6 doesn't make sense. So R is equal to 6. The speed he travels in still water is 6 kilometers per hour.